This is a proposed design of diesel power plant for Siquijor Island. Isla de Fuego. It is the name of the proposed design of diesel power plant. It is inspired from the previous name of the island Siquijor. The firm was built to supply reliable, efficient, and affordable electricity throughout the whole island of Siquijor. The proposed site for the power plant is located in the part of North Poblacion. It is a barangay in the municipality of Tlarena, in the province of Siquijor. It has an average temperature of 26.4 degrees Celsius and a relative humidity of 82%. There will be a head office to be constructed for planning, operations, meetings, and so on and so forth. The proposed diesel power plant design is considered a peak load power plant. It is expected to supply power with an estimated usage of 20 to 24 hours a day. The plant will last approximately 15 to 17 years. For the market projection, the target consumers are the residences of the island of Siquijor. The company's goal is to provide an efficient and affordable price of electricity to supply their daily needs. So this is our organizational chart. There will be a plant manager, operation manager, finance admin, and admin director, and so on and so forth. And this is their monthly salary, and this will be the table for their position, job descriptions, and the skills required for that specific positions. And this is our status and timetable of the project. On the first year, you can see that this is our proper planning, site selection, planning finalization, getting permits, securing funds or finances, and the construction propers. On the second year, it is as well on our construction proper, installation of electrical and mechanical components, installation of safety precautions, purchasing of equipments, installation of equipments, and testing the equipments. On the economic aspect of the company, on the demand, according to NSO, Siquijor Island comprises of 6 municipalities that has a population of 95,360 plus 1.01% per annum growth rate on 2015. And their economy is 10.4% below poverty line as of 2018. Total demand of electric power is at 5 to 10 megawatts at least, as people use electricity for daily activities and etc. On the supply, the province of Siquijor Electric Cooperative Incorporated, also known as Prosilco Island of Siquijor, have been the ones supplying the whole island of Siquijor. Due to tourists and population of the island rapidly increasing, there has been a shortage of supply for electric power, which resulted to several blackouts. Prosilco has a power rating of 11.7684 pesos per kilowatt hour, while Isla de Fuego, which is soon to rise, the diesel compression ignition engine that can produce power in a range from 2 megawatts to 50 megawatts. The company will most likely to have a power rating less than Prosilco, considering it can generate more power. The target of the Isla de Fuego is the residences and consumers throughout the whole island of Siquijor. The plant is set to dedicate and provide electricity without any power interruption with a reasonable and affordable price. And the company has the contribution of to the Philippine economy. Jobs will be offered to the community upon construction. 237 workers will be employed to work as full-time to run different processes of the plant, given with various benefits.
Technical feasibility. Our product is a designed power plant compromises of diesel compression engine that can produce 2 megawatts up to 50 megawatts. A diesel engine converts some of the chemical energy contained by diesel fuel to mechanical energy through combustion. The plant is set to assure to provide efficient electricity supply without any power interruption to the island of Siquijor. This is the load requirement for the island of Siquijor. It has the average kilowatt hour per household for residential and commercial. This is the residential calculation and the commercial calculation. And This table is the total power demand calculation. Then on the right side, you can see the load curve for Siquijor on an average day. The x-axis represents the loads in kilowatt and the y-axis represents the time in hours. For load factor calculations, for residential, the average load is 6,398.1 kilowatt hour divided by 24 hours is equal to 255.924 kilowatt. The maximum load for each residential is 8,8695 kilowatt. So the load factor is 6,398.1 divided by 24 hours times 410.8695 kilowatt is equal to 0.649. And for the commercial, the average load is 7,819.9 divided by 24 hours is equal to 312.796 kilowatt. And the maximum load for a commercial building is 552.17 kilowatt. And to get the load factor, you get the average load divided by the maximum load and it is equal to 0.59. This is the total power demand per month for the island of Siquijor. Since the diesel power plant can generate up to 50 megawatts to supply the island of Siquijor, and the island only needed at least 5 megawatts of power demand per month with an average power consumption of 2.8783 megawatts per month, and the power plant is estimated to run every day with at least 2 to 3 hours maintenance every week. And this is the operation schedule for the diesel power plant. We have the unit 1 and 2 which will continuously operate for 24 hours with a 12 hours alternate for each unit, and having the unit 3 and unit 4 as backup generator for peak loads. And we have 2 shifts for our production, which is from 7 a.m. to 6:30 p.m. and 6:30 p.m. to 7 a.m. The work schedule is from Monday to Sunday, and we have a maintenance of at least once a week every Tuesday, 7 a.m. to 10 a.m. For our plant capacity, we have 4 units overall, and we have 3 units of 680 kilowatt and 1 unit of 410 kilowatt. It is a total of 2,450 kilowatts. Then plant capacity factor is equal to energy generated divided by plant capacity times operating hours. So we have 6,398.1 kilowatt hour divided by 2,450 kilowatt hour times 24 hours. So we have a plant capacity of 0.1088. That is for the residential, and for the commercial, we have a 0.1330 plant capacity factor. Machinery. We have first for our units in 1, 2, and 3, we have the Caterpillar C27 diesel generator. It has a capacity of 60 hertz. It has a prime 680 kilowatt and a standby of 750 kilowatt. It has a stroke of 152.4 mm and a compression ratio of 5:1. Next is our machinery for Caterpillar C15 diesel generator for unit 4. It has a capacity of 60 Hz, prime of 410 kilowatt and a standby of 450 kilowatt, and a stroke of 171 mm and a compression ratio of 16:1:1. Then for our evaporative condenser, we have the NZL China evaporative condenser. It has a connection size of inlet of DN80 and outlet of DN80. And next is our fuel oil storage. It is a 20 feet diesel fuel oil storage tank. This is the plant layout of our diesel power plant.
Financial feasibility. In this part, I will discuss about the project's cost, depreciation, financial ratios, assumptions, and the break-even point. This is the project's cost. We have 3,298,495 pesos cost of land and building construction, 21,241,600 pesos for the cost of machineries, and the operational costs daily, monthly, and yearly. This is the depreciation of our building and machines. The building has 2% depreciation rate, and by its estimated life, all rooms in the building has zero salvage value. For our machines, we have depreciation rate of 45% and 50% for our 680 kilowatt and 410 kilowatt generator respectively. 5% for the cooling tower and 10% for fuel storage tank. Salvage value at their estimated life is also shown. For our initial cost, we have here the sum of cost of our land, building construction, and machineries. We would be needing 25 million pesos for our capital. For our source of our financing, we choose BDO and Security Bank with interest rates and terms of 8% for 5 years and 8.25% for 3 years respectively. For our electricity rate, we calculate it using this formula. Annual production cost over power plant capacity multiplied by 0.8. Since we assume that only 80% of the total generated energy arrives in the customer's meter. With that, we get 225,745,000 of revenue annually, which increases 2.1% every year along with the electricity rate. Here is our income statement and our financial statement, with assumptions of annual percent increase for raw materials, utilities, labor, and maintenance. Here is our current ratio, debt ratio, and asset turnover. And here is how we calculate our payback period. It is initial cost plus interest over annual profit. With this, our payback period would be in 3.6 years or 4 years. Here is our ROE, return on equity, and ROI, return on investment. In our break-even point, we have a formula of fixed cost over the difference of the selling price and the variable cost. We found out that our plant has to produce more than 9,400,000 kilowatt-hour to gain profit. On behalf of the other group members, John Lester Escobedo, Marie Arch Anthony Cotihar, and I, Jeric Joseph Colico, thank you for listening. God bless and stay safe.